Good morning. Today we're going over units in the metric system, and this is our first homework assignment for our chapter on math and chemistry. And so let's get started. This first question is on uncertainty. And again, I'm never going to actually test you on significant figures, but I want you to understand why we've got these kind of rules about significant figures. So first of all, we're looking at this circle and we want to measure the diameter or the distance across the farthest 2 points. And they give us two rulers, ruler A, which has tick marks every half of a centimeter, and ruler B, which has tick marks every millimeter. And they want us to say which of these digits is significant and which are not. And they give us some rules, but I hope you can see this. Let's start. If I pick up this circle and hover it over here, then by looking at this ruler, I can tell for sure that it's at least 2 centimeters. It's not quite 2.5 centimeters. It might be 2.3, it might be 2.2, it might be 2.25, but we're not really sure exactly what that second digit is. So I'm going to say 2.2 about. I mean, I really can't tell whether that's a 2 or a 3. And that's because we don't have additional tick marks. So you can see by that we've got one certain digit. We know that it's 2 centimeters, and one uncertain digit. We don't know exactly how many millimeters it is, but it's approximately 2 additional millimeters past the 2 centimeters. This one will give us a clearer picture. Okay, now I can say for sure it's 2 centimeters. And for sure, it's at least an additional 2 millimeters. And it looks like we're halfway between that 2 and that 3. So I'm going to say 2.25. So that gives us now 2 certain digits and one that is uncertain. I'm not exactly sure whether it's 2.25 or 2.26. It's hard to tell. Ooh, they're going to tell me they want a better 2.26 maybe. There we go. See, I couldn't quite tell whether it was 2.25 or 2.26 because this last digit is a little bit squishy. Okay, so now that we've measured, we can say that ruler A, this one up here, had one certain digit and one that was uncertain. One certain, one uncertain. That means 2 that had any significance. In other words, I could say that it's 2.253495 centimeters, but that would be ridiculous. I don't know what all those digits are. They're not significant. They're insignificant. And ruler B then had 3 significant figures. And the first 2 of those digits were certain. We knew that it was at least 2.2. And the last one was uncertain. It's kind of a quick and dirty way to indicate how precise your measurement is. Next, we're converting between regular notation and scientific notation. So if my decimal point goes here at the end of the 0, then I'm going to move it back by 1, 2, 3, 4, 5, 6 positions to make 1.34 times 10 to the 6th. For this next one, since I'm going backwards, by 1, 2, 3, 4 positions, that I have 3.54 times 10 raised to the -4th. Big numbers will have positive exponents. Small numbers will have negative exponents. Now ranking these in order of size from largest to smallest, let's look at the exponent. 10 to the 6th is the largest exponent we have, followed by 10 to the 5th, then 10 to the 4th, then 10 to the 3rd, and then 10 squared. So just by looking at the power of 10, that tells me which is the largest value and which is the smallest value. Going the other direction, because this is times 10 to the 3rd, that's a positive number, I'm going to move this decimal point to the right by 3 points. That makes it 3140. And because this is 10 to the -4th, I'm going to move this decimal point to the left to make this 1, 2, 3, 4 digits. And I moved that decimal point, 0.000875. Now going between scientific and standard notation again, because this is 10 to the negative 1, that is 0.27. I've moved this 1 position to the left. I'm going to move this 3 positions to the left, so I'm going to add in 2 zeros, 0, 0, 2, 4. And 1 position to the left, 0.10. And because they included 1 0 after the 1 and after the decimal point, they want you to include that to indicate precision. So if you put just 0.1, it's going to mark you wrong because it's not as precise. Again, I'm not going to test you on significant figures, but that's what they would be penalizing you for here. And again, if you miss it, not a big deal because you get a whole bunch of extra points. So don't stress over it. Just make sure that you know how to do the scientific notation thing here. That's what I really want you to pull away from this. Your numbers might be slightly different than mine because they're a little bit randomized, but the process is the same. And going the other direction, this is times 10 squared. So I'm going to move this decimal point by 2 positions. So 670. And I'm going to move this 1 to the left by 1. Move this decimal point to the left by 2 positions. And I'm going to move this one to the right by 4 positions. So this is the same type of question that's asked in a multiple choice format. I do this because your exams are multiple choice format, so I want you to be able to answer it in that kind of way. So if we are making that scientific notation, note we're going to move this to the right by 1, 2, 3 positions to give me 4.6 times 10 to the negative 3 because it's a small number. So it's going to be that one. Which metric unit is used to measure volume? That is the liter. Liters, milliliters, microliters, those are all volumetric measurements, and the liter is the parent of them. A meter measures length, Kelvin measures temperature, gram measures mass, and gram per cubic centimeter would be a measurement of density. So this problem is converting between metric prefixes. And they give us a little table here that's not exactly the same as the table you've got in lecture notes, but it'll work for the moment. And what you see is they give you a prefix and they tell you what it means and they give you a value. And if you can memorize the prefix and the value and apply it like we do right here, then you'll be great. So here they say 813 milligrams equals how many grams? And here's what I want you to see. 1 milligram is equal to 1 times 10 to the negative 3 grams because it's got this value of 10 to the negative 3. So for this equivalency, 1 is 1, and milli is 10 to the negative 3, and grams is grams. That's why 1 milligram equals 1 times 10 to the negative 3 grams. So if I apply that here, I see that 813 milligrams is equal to 813 becomes 813, milli becomes 10 to the negative 3, grams stays grams. So 813 milligrams is 813 times 10 to the negative 3 grams. And then because 813 times 10 to the negative 3 becomes 1, 2, 3, becomes 0.813 grams. Here going from deciliters to milliliters, I think it's easiest to actually just go through liters. So I'm going to say 11.4 deciliters is equal to 11.4 deci means 10 to the negative 1 times 10 to the negative 1 liters. So that is 1.14 liters, 1.14 liters. Now to take that to milliliters, I know that 1 milliliter is equal to 1 times 10 to the negative 3 liters. So since 1 milliliter is equal to 1 times 10 to the minus 3rd liters, if I can get this to say times 10 to the minus 3rd, then I will have the milli prefix. So 1.14, to move this so that I get minus 3, I'm going to move it 1, 2, 3. So that gives me 1140 times 10 to the minus 3rd liters, right? I just took this value, I moved the decimal place until my scientific notation said 10 to the minus 3rd, and I still have liters. And now I can substitute milli for 10 to the minus 3rd, because that's what milli means. So that means 1140 milliliters. Next, write the symbol for the following units. Hecto is a little h. I'm not going to test you on deca or hecto, by the way, only on the stuff that's listed in the lecture notes. Kilo is a little k. Nano is a little n. And mega is a capital M. Oh, I need to submit these. Oh, I'm sorry, hectoliter. Little h for hecto, big L for liter. Little k for kilo, little g for gram, little n for nano, little m for meter, so that's nm is nanometer. Capital M for mega, little m for meter, megameter. C, little c is centi, big L is liter, so that's a centiliter. NM is nanometer. That mu means micro, and that M means meter. K is kilo, M is meter. Kilometer. Again, there's the micro. In this case, it's a microgram. And here we have a kilogram. Now converting milligrams to centigrams, kiloliters to megaliters, micrometers to milliliters. All right. And in some respects, it might be easiest to write these out and just move our decimal points kind of to the left and to the right. So 3.614 milligrams. Milli means 10 to the negative 3. So that is 3.614 times 10 to the negative 3 grams. Now they want centi, and centi is 10 to the negative 2. So to make this 10 to the negative 2, I've got to move this back this direction. That's 0.3614 times 10 to the negative 2 grams. So that is 0.3614 centigrams. Kiloliters to megaliters. 12 kiloliters equals 12, kilo means times 10 to the third, liters. Megaliters is 10 to the 6th. So in order to get 10 to the 6th, we are going to need to move this by 3 more positions. So that's going to be 0.0120 times 10 to the 6th liters. So that gives us 0.0120 megaliters. Just note that anytime I want to make that exponent bigger, I have to move this decimal point to the left. Like I did here, going from negative 3 to negative 2, that's making it larger. Going from micrometers to millimeters, so 14.4 micrometers equals 14.4 times 10 to the negative 6th meters, because that's what micro means. Milli is 10 to the negative 3, so I'm going to need to make it 3 places bigger, so I'm going to need to move it to the left by 3 places. So that equals 0.0144 times 10 to the negative 3 meters. So that equals 0.0144 millimeters. Centigrams to nanograms. 6.03 times 10 to the negative 6th centigrams equals, oh my. Now we've got an exponent plus the centi. Why would they do that? So that is 6.03, and the centi means 10 to the negative 2. And so those are actually added together. So that is times 10 to the negative 8 grams. Now, if they want nanograms, nanograms is 10 to the negative 9. I need to make that one smaller. Negative 9 is smaller than negative 8. So I'm going to move this the other direction. That's going to be 60.3 times 10 to the negative 9 grams, which is the same as 60.3 nanograms. When you multiply numbers with exponents, you add those exponents together. That's what we did there. All right, let's clear our palette and keep going. 174.5 milliliters to deciliters. Milliliters equals 174.5 times 10 to the negative 3 liters. Deca is 10 to the negative 1. So in order to get that to 10 to the negative 1, I'm going to move that over. 1.745 times 10 to the negative 1 liters, which is 1.745 decaliters. Now, by the way, this isn't the only way to do it. There are several other ways to do it. One thing would be to say, all right, if I know that milliliters is 10 to the negative 3 and deciliters is 10 to the negative 1, then what I need to do, I'm off by 2 decimal places, so I need to move it 2 decimal places to the left. That's all. Move 1, 2, and you would be done. Just looking at those exponents and what you're moving there. If you could do that, great. Whatever method you can do, so long as it gets you the right answer, is okay. It's right. All right, 1.5 times 10 to the minus 2 kilometers. I'm just showing you one way that works for me, and if I'm consistent, then hopefully it'll work for you. Otherwise, if you have your own method, that's great. So kilo is 10 to the third. So 10 to the negative 2 times 10 to the third gives me 10 to the 1. So 1.5 times 10 to the 1 meters, or 15 meters. And they want that in centimeters. We want that 10 to the negative 2. So 10 to the negative 2, I'm going to move it to the right by 2 positions. So that's 1,500 times 10 to the negative 2 meters, or 1,500 centimeters. Otherwise, you could say 1.5 times 10 to the negative 2 kilometers. You could say kilo is 10 to the third, centi is 10 to the negative 2. So that's, you have to move it over by 5 positions. So from here, 1.5, move this over 1, 2, 3, 4, 5. But this is times 10 to the minus 2, so I'm going to move it back by 2, and that's going to give me 1,500. All right, which one is the largest quantity? The easiest way to do this is to convert them all to the same unit, whatever it is. I mean, they're all in grams, but we got milligrams, nanograms, micrograms, kilograms. Let's just convert them all to grams. So the top one is 4.73 times 10 to the negative 4th grams. Next, if I have 47.3 milligrams, I have 47.3 times 10 to the negative 3 grams, because that's what milli means. Next, I've got 4730 times 10 to the negative 9 grams. And then we've got 4.73. Micro is times 10 to the negative 6th. So 10 to the negative 6 times 10 to the third is 10 to the negative 3. 10 to the negative 3 grams. And then kilo is 10 to the third. So 10 to the third times 10 to the negative 6 gives me 10 to the negative third, because you add those up. So again, 4.73 times 10 to the negative 3 grams. All right, so first of all, these two are the same, and they're definitely smaller than this one. All three of these have 10 to the negative third, but these are 4.73, and that's 47.3. So we can eliminate these because we know that they are smaller than this one. And now for these ones, 47.3, I need to get all of these into the same power of 10. So 10 to the negative 4th If I want to make that 10 to the negative 3, I've got to move this over, and I have 0.473 times 10 to the negative 3. That is also smaller than this one, so we can eliminate this one. And 4730 times 10 to the negative 9th, if I want to move that to 10 to the negative 3rd, I have to move this over 1, 2, 3, 4, 5, 6. So that's going to be 0.004730 times 10 to the negative 3 grams. And this is still the biggest one. So 47.3 times 10 to the negative 3rd, or 47.3 milligrams, is the largest. Next, again, this is one of these questions we've already been doing, but now I'm asking it in a multiple choice format. So going from milligrams to nanograms, 5.2 milligrams. Milli is 10 to the negative 3. So that is 5.2 times 10 to the negative 3 grams. Nano is 10 to the negative 9th. So if I'm making this smaller, I've got to move it over by 6 positions. So 5.2, that moves 1, 2, 3, 4, 5, 6 nanograms. And that becomes 5.2 times 10 to the 6th. I hope this was helpful. Have a great day.